All right, looks like we're going here. Yep, we are. All right, so today we're looking at what's called an arithmetic sequence. So when we have a look here, here's the example. It says arithmetic sequence 2, 5, 8, 11, 14, and I've said it's an arithmetic sequence. Why? Well, when you have a look here, 2 to get to 5, you can add 8. Add 8, what am I talking about? Add 3 to get 8 to 5. Then to get 8, we add 3. And then we can add another 3 and we get 11, another 3, and we get 14. So you can see, because we're adding the same number each time. All right, same would happen if we were subtracting the same number each time. So let's have a look. Oh, so the first term is 2, I should say, and yeah, it's term 1. And in terms of arithmetic sequence, we use the symbol A. Then the next term, term n plus 1, you take a term n, and then you add your 3 each time, and so on and so on. So what we could say then is the term n plus 1, the next term, is this term plus some number. Now that number there we call the difference, and we use the symbol D, the difference between the two. And so that D could be a negative number. Say we were taking 5, then we'd say the difference was -5. All right, so the nth term of a sequence, so that's all very nice for our recurrence, but we like to know the nth term. So the nth term, the explicit relation, can be found by, so term n will be where we start plus a certain number of times the difference. Well, and the number of times the difference is 1 minus the term that we're looking at. All right, so here 14 is 2 plus 4 times 3, and term 14 is 1, 2, 3, 4. It's the 5th term. All right, so where n is your term number, I haven't given myself a lot of space here. M is the term number. A is your first term, and D is your difference, or more correctly, your common difference. Okay, so more correctly, common difference, because it's common to every term. It's the difference between the one before in it and then the one in the next one, so it's common. It doesn't, you could have difference changes, but that would not be an arithmetic sequence. Arithmetic sequence has to have the same. So here it says find the 10th term in the arithmetic sequence. All right, so we know that we want n equals 10. We know that A, the first number, is -4. So then let's have a look at the difference. So what's the difference between, so to get your difference, just take any term and subtract the one before it, but so 2, subtract the one before it, so it's 3, so the common difference is 3, and you probably already picked that up. All right, so term 10 then, using this formula, term 10 is equal to A, which is -4, plus n, 10 minus 1, times the difference, which is 3. Get out your trusty calculator if you need to, and put that in, or you could do it by hand. And then you get 23. All right, so that's one type of question you could get. Another type of question is like this. If 170 is the nth term, so term n equals 170. The sequence is this here, so the first term is 200. The difference to go from 200 to 197 to 194 to 190, we're taking 3 each time. And what do we want to know? We want to know n. So using that same formula, term n is a plus n minus 1 times the difference. And we know term n is 170 equals a, 200, plus n minus 1 times negative 3. Let's work it out. I'm going to take 200 from both sides. And so negative 30 equals n minus 1 times negative 3. I'm going to divide by negative 3 both sides now. Then add 1, so n equals 11. All right. There is ways, of course, on your calculator you can figure that out. But I'm not going to show you that. Yes, I will. I will show you that. So if you wanted to do that on your calculator, what you would do is this. We'll go here to our second page. So remember, it's the second page. Sequence. I'm going to use the recursive. Let's clear all of that. So in this case, what did we say? We took this one and we take 3 from it. I think, do we? We take 3 and then we take 3. And we started the first term, n equals, whoops, so I better change to this one. All right, so let's go back. Term, we take 3, and our first term was 200, I believe. Yep, 200 was 200. Figure that out, and then you just scroll down. There we go. 170, term 11. All right. So the value of n, 11. Let's have a look at another one. So this one here, the 12th term is 9. The 25th term is 100. Find A and D. So here we've got 2 things that are missing. All right. So we still start using the same thing. So term n equals A plus n minus 1 times D. 12th term, term 12 of the arithmetic sequence is 9. So when n equals 12, 9 is equal to A plus 12 minus 1 times D. So 9 equals A plus 11D. 25th term, n equals 25, is 100. So 100 equals A plus 25 minus 1 times D. So 100 equals A plus 24D. And now we've got 2 equations and we solve them simultaneously. So you can do it by hand or you can do it by calculator. I'm going to bring this one over here. And I'm going to subtract. So 100 minus 9 is 91. A minus A is 0. 24 minus 11 is 13D. Divide both sides by 13. Let's have a look. I'm going to use my calculator. So 91 divided by 13. 7. So D is 7. And then I'm going to shove things in here. So 9 equals A plus 11 times 7. So 9 equals A plus 77. So A is 9 minus 77, which is negative 68. So there's our A and our D. All right. You could, of course, use the simultaneous equation solving template on your calculator to do that, but just as easy to do by hand, depending on how proficient you are. All right, and of course, just a reminder that you are expected to be able to solve two variables by hand for simultaneous. All right, the next thing is the arithmetic mean. So in this term, arithmetic mean of two numbers is defined as A plus B over 2. So it's just, and that equals C. So if you've got two numbers, add them together, divided by 2, that puts another number right in the middle. And that number right in the middle is C. So for example, if I have the numbers 2 and 4, simple, I want to find out 2 plus 4 over 2, 6 over 2 is 3. And so that number 3 is bang right in the middle, so it's one either side, isn't it? So if you've got a sequence of consecutive numbers, then the middle one would be the arithmetic mean of these other two. All right, so let's have a look at an example. So example, if A minus 4 and 8A minus 13 are consecutive terms, so the key thing here, consecutive terms of an arithmetic sequence, find A. So they're consecutive. So as I mentioned up here, for A, B and C, then this C in the middle is the arithmetic mean of these two outside ones. So my A minus 4 is the arithmetic mean of 4A minus 4 is the arithmetic mean of A and 8A minus 13. And what we're asked to find is find A. Now, the word arithmetic means is quite important, all right, because we're arithmetic sequences here. So we're adding the same amount. So that's why arithmetic comes into it. All right, so if that's the case, to find the arithmetic mean, which is 4A minus 4, we would need to add the two terms and divide them by 2. All right, so what I'm going to do is times both sides by 2 and get through to those two, and I'm going to collect my like terms here as well. This side I've got 8A minus 8, and then I've got 9A minus 13 there, and then let's at the same time, so what I'm going to do is take 8A from both sides, and I'm going to add 13 to both sides at the same time. Minus 8 plus 13 should be 5, I hope. 9a minus 8a is a, so a is equal to 5. So we just asked for a, but a is equal to 5. Then the next one, 4 5s are 20 minus 4 would be 16. The next one, 5 8s are 40 minus 13 is 27, I believe, I hope. 5 8s are 40 minus 13, so 30, yeah, 27. All right, and so there's our arithmetic, there's our A to form that arithmetic sequence where this is the middle number of those two. All right, so it's 11 each way, of course. All right, so that's it as far as arithmetic sequences are concerned. So some practice questions for you guys in your textbook. As always, have fun, and when you need help, get back to me.